Hello everyone. Previous lecture we see concept related with the matrices, and in that we see how to find the solution of linear equations by using the matrices. And for this we see one method, and this method is inversion method. That is, by using the inverse of matrix we find solution of linear equation. So in today's lecture we go with some examples related with the solution of linear equations. Let's go with first one. Here in first, system of linear equation is given. Here given x plus y plus z is equal to 1 is the first equation. Then here y plus z is equal to 2 is the second one. And in third, here x plus y minus z is equal to 3. So we have to solve these three examples. That is, by using the inversion method we have to find values of x, y and z. Okay, so here given equation can be written as, here the given equation can be written as here in the first matrix we consider the coefficients of variables. That is, for the first equation here coefficients of x, y and z are here 1, 1 and 1. So we consider this first equation for the first row. Then here we consider second equation. Here coefficients of x, y and z are here 0. Then for y it is 1 and for z it is also 1. Then for the third equation, here coefficients of x, y and z are here for x 1, here for y it is 1, here for z it is minus 1. So we consider this matrix and is having coefficients of the variables x, y and z. Then in second matrix we consider the variables. Now we know in this equation, in these three equations, here variables are x, y and z. So we consider column matrix for this. Now this is equal to, here for next we consider the constants. Here in RHS given constants. So here first is 1, then for second it is 2, then for third it is 3. So we convert given equations into form. Here Ax is equal to B. Okay, here we consider matrix A. Okay, I write here where A is equal to matrix having coefficients of variables, and in this matrix first row is having 1, 1, 1. Then for second row here 0, 1, 1. Then for third here 1, 1 minus 1. Okay, then here capital X is the second matrix and is having the coefficients, here variables. Here variables are x, y and z. Okay, then in last we consider matrix B, and this matrix B is for constants. Here constants are 1, 2, 3. We consider column matrix for this. Here 1, 2 and 3. Okay, so using this A we find inverse of A to find the values of the x, y and z. Okay, here we consider the equation. We consider the given equation, that is here form Ax is equal to B. Okay, here we pre-multiply by A inverse for the both sides. So we get here A inverse into Ax is equal to here A inverse into B. Okay, then here I write this as here A inverse A into X is equal to A inverse B. Here everyone knows A inverse A is the identity matrix. So here I into capital X is equal to here A inverse B. Okay, and we know here identity matrix into any matrix is always the matrix itself, that is this X. So here X is equal to A inverse B, and by using this form we find the solution of given equations. Let us consider this as 1. Now our first step is we have to find inverse of given matrix A. Okay, so we consider given matrix here. Now as here given A, and this A is having elements here 1 1 1, then for second row here 0 1 1, and for last row here 1 1 minus 1. Okay, firstly we check whether inverse of given matrix A exists or not, and to check this we consider determinant of A. Here determinant of A is equal to, okay, here we consider first row for the calculation. Here 1 into bracket, here 1 into minus 1 is minus 1, then here 1 into 1 is minus 1. Then we consider second element of the first row. Here it is 1, so with minus sign 1 here inside the bracket. We know here position of this 1 is in first row and in second column, so we delete first row and second column, and we consider remaining elements for the calculation. Here 0 into minus 1 is 0, then 1 into 1 is 1, so with minus 1. Next here plus 1 into, here this 1 is in first row and is in last column, so we delete first row and last column, and we consider remaining elements for the calculation. Here 0 into 1 is 0, then with minus sign here 1 into 1 is 1. Okay, now this is equal to here 1 into, everyone knows minus 1 into minus 1 is minus 2, then minus 1 into bracket this minus 1. Next here plus 1 into, again we know 0 into minus 1 is minus 1. Okay, now this is equal to, here 1 into minus 2 is minus 2, then plus 1, then minus 1. And lastly here we get minus 2, and we know this minus 2 is not equal to 0. If determinant of A is not equal to 0, then we say inverse of given matrix exists. Inverse of given matrix exists. Okay, so here we consider inverse is exist. Now we find this inverse by using here either by transformation method or by here adjoint method. Okay, let's find inverse, this inverse by using adjoint method. Okay, so here again to find the inverse we consider this matrix A. Okay, so here first element is A11. Here A11 is 1. This is equal to, here everyone knows here 1 is in first row and is in first column. So to find the minor we delete first row and first column. Okay, so here M of 1 1, here M11 is the minor of the element A11. Okay, so M11 is having here 1 into minus 1 is minus 1, then with minus sign here 1 into 1 is 1, and this is equal to minus 2. Okay, now we find here adjoint. Here adjoint of, here we find cofactor of the element A11. Okay, here capital A11 is the cofactor of the element A11 and is here minus 1 raised to 1 plus 1 into minor. Here minor is minus 2. So here minus 1 square is 1 and 1 into minus 2 is here minus 2. So this is the cofactor of the first element. Next we find here minor of the element A12. Here A12 is 1. Okay, its minor is M12 is equal to, Here to find the minor, we delete first row and second column and we consider remaining elements for the calculation. Here 0 into minus 1 is 0, then with minus sign, here 1 into 1 is 1 and is equal to minus 1. Okay, let's find its cofactor. Here A12 is the cofactor of given element and is here minus 1 raised to, here 1 2 is given, so we consider 1 plus 2 into minor of given element. Here minor is minus 1, okay, and this is equal to, we know minus 1 cube. Minus 1 cube is minus 1 and minus 1 into minus 1 is plus 1. Next, here next element is A13 is equal to, here A13 is 1, okay, we know minor of this element is M13 and this is equal to, everyone knows this A13 is in first row and in third column, so we delete first row and third column and we consider remaining elements, that is 0 1 1 1 for the calculation. Here 0 into 1 is 0 with minus sign, here 1 into 1 is 1 and is equal to minus 1. Now we find its cofactor. Here A13 is the cofactor of given element and is here minus 1 raised to 1 plus 3 into, here minor is a minus 1, so this is equal to, we know minus 1 raised to 4 is plus 1 and 1 into minus 1 is here minus 1. Next, here next element is A21, we know here A21 is 0, okay, here minor of this element is M21 is equal to, we know A21 is in second row and is in first column, so we delete second row and first column and we consider remaining 1 1, this 1 minus 1 for the calculation. So here 1 into minus 1 is minus 1, then with minus sign, here again 1 into this 1 is 1 and is equal to minus 2. Now its cofactor, here A21 is the cofactor of given element, okay, here A21 is minus 1 raised to 2 plus 1 into, here minor is minus 2. Now here we know minus 1 cube is minus 1 and minus 1 into minus 2 is here plus 2. Next, here A22 is equal to, here for A22 we consider 1, okay, this one. Next, here its minor is M22 is equal to, here to find its minor we delete second row and second column and we consider remaining elements for the calculation. Here 1 into minus 1 is minus 1 with minus sign, here 1 into this 1 is 1 and is equal to minus 2. Next, its cofactor is A22 and is minus 1 raised to 2 plus 2 into, here minor is minus 2 and this is equal to, here minus 1 raised to 4 is plus 1 and 1 into minus 2 is minus 2. Next, for next element A23 is equal to, here A23 is 1, okay, we know its minor is M23 is equal to, we know this A23 is in second row and in last column, so we delete second row and third column and we consider remaining elements for the calculation. So here we consider 1 into 1 and is 1 with minus sign, here again 1 into 1 is 1 and is equal to 0. Now its cofactor, here A23 is equal to minus 1 raised to 2 plus 3 into, here minor is 0, and we know here 0 into minus 1 is 0. Then for next element, here A31 is equal to, here A31 is having 1, okay, then here its minor is M31 is equal to, here A31 is in last row, that is third row and in first column. So we delete third row and first column, and here we have only 1 into 1 is 1 minus again 1 into 1 is 1, and this is equal to 0. Okay, now here A31 is equal to, here minus 1 raised to 3 plus 1 into 0. We know minus 1 raised to 4 is plus 1, and 1 into 0 is here 0. Okay, then for next element, here it is A32 is equal to, we know A32 is 1, okay, so this is equal to 1. We know its minor is M32 is equal to, we know this A32 is in third row and in second column. So we delete third row and second column, and here we have only 1 into minus 1 is, sorry, 1 into 1 is 1 with minus sign. Here 0 into 1 is 0, and this is equal to 0. Now its cofactor, here its cofactor is A32 and is here minus 1 raised to 3 plus 2 into, here minor is 0, and this is equal to, we know minus 1 raised to 5 is minus 1, and minus 1 into 0 is 0. And for the last element, here A33, okay, here A33 is minus 1, okay, this is equal to minus 1, then its minor is M33, and to find the minor we delete third row and third column, and we consider remaining elements. Here 1 into 1 is 1, then with minus sign, here again 0 into 1 is 0, and this is equal to 1. This is equal to 1. Okay, so here its cofactor A33 is equal to, its cofactor is here minus 1 raised to 3 plus 3 into, okay, here it is 1, and this is equal to minus 1 raised to 6. Minus 1 raised to 6 is plus 1, and 1 into 1 is 1. Here please note, here 1 minus 0 is 1, and here A32 is here minus 1 raised to 3 plus 2 into 1, and this is equal to here minus 1. Now check this. Okay, so we find all the cofactors of the all elements. So here cofactor matrix is, therefore cofactor matrix is equal to this matrix having elements here A11, A12, A13. Next here for second row A21, A22, A23. Then for last row here A31, A32, A33. So we consider these elements. Now this is equal to, we know here A11, A12, A13. Here A11 is minus 2, 12 is 1, and A13 is minus 1. So minus 2, 1, minus 1, minus 2, 1, minus 1 for first row. Then for second A21, A22, A23. Here A21 is 2, then 2 is minus 2, and here 0, that is 2 minus 2, 0. 2 2, minus 2, 0 for second row, and for last here A31 is 0, okay, then A32 is minus 1, and last A33 is 1. So we find the cofactor matrix. Now by using this cofactor matrix we find adjoint of A, okay. So here, therefore here adjoint of A is equal to, we know adjoint of A is the transpose of this cofactor matrix. Transpose means here we replace our first column by using the elements of first row, that is minus 2, 1, minus 2. This minus 2, 1, minus 1 is for first column. Then we replace the second row for the second column. Here 2, minus 2, 0. Here 2, minus 2, 0 is for second column. And for the third column, we consider elements of third row. Here elements are 0, minus 1, 1. Here 0, minus 1, 1. So this is the adjoint of A. Now we consider this adjoint of A to find the inverse of given matrix. Okay, so here A inverse, therefore here A inverse is equal to 1 upon determinant of A into adjoint of A. Okay, now this is equal to, we know here determinant of A. Here we calculate determinant of A in first, and this is minus 2. Then here adjoint of A is having matrix having elements minus 2, 2, 0, then 1, minus 2, minus 1, and for last row minus 1, 0, 1. So by using this inverse, we find the solution of given equations. And by using 1, in 1 we consider, here I write using 1, in 1 we consider x is equal to A inverse B. Okay, here for x we consider the matrix having the variables. Here variables are x, y, z. Okay, this is equal to, then here A inverse is having 1 upon minus 2. Then inside the matrix our elements minus 2, 2, 0. For second row 1, minus 2, 1. Then for last here minus 1, 0, 1. Okay, then for matrix B we consider constants. In this example our constants are here given minus 1, 2, 3, minus 1, 2, 3. Okay, so by using the calculation, by using the product of these two matrices, we find the variables. So here, therefore here in the matrix having variables x, y and z is equal to, here we keep this 1 upon minus 2 as it is. Now consider this first matrix. This first matrix is having order 3 by 3. Then the second matrix, that is matrix of constant, is having order 3 by 1. Now we check whether the product of given two matrix is conformable or not. And to check this, we consider number of columns of first matrix and number of rows of second matrix. Here number of columns of first matrix and number of rows in second matrix are same, that is 3, 3. So here product is conformable, and new matrix is having order here 3 by 1. New matrix is having order 3 by 1. Okay, so here we know matrix of the order 3 by 1. Standard matrix of the order 3 by 1. Here we consider standard matrix, here having A1, 1, here A2, 1, and here A3, 1. We consider only these three elements. and this matrix is having order 3 by 1. Okay, now here to find the first element, that is A11, we consider first row and first column, that is product in first row of first row and first column. We consider the corresponding elements, that is here minus 2 into 1 is here, sorry, minus 2 into minus 1 is here 1 only, sorry, here 2. Okay, so here 2, then here 2 into this 2, we know 2 into 2 is 4, so 4, then next 0 into 3 is 0, so this is for first element. Now here middle element is A21, that is we consider second row and first column for this element. So here 1 into minus 1 is here minus 1. Next minus 2 into 2 is minus 4. Next here 1 into 3 is 3, that is plus 3. Okay, this is for the second element. And for last we consider A31, that is third row and first column. Here in third given minus 1. So minus 1 into minus 1, we know it is 1. Next here 0 into 2, we know 0 into 2 is 0. Then here 1 into 3, here 1 into 3 is 3. So here elements are like this. Now this is equal to here 1 upon minus 2, then inside the matrix we consider here 2 plus 4. We know 2 plus 4 is 6. Next, here minus 1 minus 4 is minus 5. Minus 5 plus 3 is minus 2. Then for last, here 1 plus 3 is 4. Okay. So this is our matrix. So here in LHS given X, Y and Z. This is equal to, now we divide each element by minus 2, this minus 2. So we get here minus 3, then 1, then here minus 2. Okay. So by using equality of matrices, by equality of matrices, we get here x is minus 3, that is we equate first with first, then here y is equal to 1, second with second, next here z is equal to minus 2. So we find x, y and z by using the inversion method, that is by using the matrix. Okay, so very simple example it is, by using the inversion method we find the solution. So this is our first example. Let's go with our second example. Here in second, given 5x minus y plus 4z is equal to 5, then 2x plus 3y, then plus 5z is equal to 2. And for last equation, here 5x minus 2y, then plus 6z is equal to minus 1. Again, by using the inversion method, we have to find the solution of the given equations. That is, by using the matrices, we have to find here x, y and z. Okay, so here given equation can be written as the given equation can be written as here in the first matrix we consider coefficients of the variables. Here in the first equations coefficients are here 5 minus 1 4, Then in the second, coefficients are 2, 3, 5. Here in the last equation, 5 minus 2, 6. Okay, so this matrix is having coefficients of the variables. Then in the second matrix, for the second matrix, we consider the variables. Here, in these three variables are x, y, and z. Now, this is equal to, here we consider matrix B. That is, this is the matrix having the constants. Here constants are 5, 2, minus 1. Now, this is in the form, here Ax is equal to B. Okay, where here A is the matrix having elements 5, minus 1, 4, then 2, 3, 5, then for last row, here 5, minus 2, 6. Then here X matrix is having the variables, that is X, Y, and Z. And for last, here B is equal to matrix having the constant, that is 5, 2, minus 1. Okay. Now, we consider this equation. We consider Ax is equal to B. Consider Ax is equal to B. Okay, that is this equation. Pre-multiply given equation by A inverse. So here A inverse into bracket Ax is equal to here A inverse B. Now here I write this as A inverse A into X is equal to A inverse B. Now everyone knows here A inverse A is the identity matrix. So here X is equal to A inverse B. Again, we know here identity matrix into X is X itself. So here X is equal to A inverse B. And by using this relation, we find the solution of given equation. So our first step is we have to find inverse of this A. So we consider A again. Now, as here A is equal to matrix having elements 5, 1, minus 1, 4, then 2, 3, 5, and for last row, here 5, minus 2, 6. Firstly, we check whether inverse of given matrix exists or not. And to check this, we find determinant of A. Here, determinant of A is equal to, here we consider first row to find the determinant. Here 5 into bracket 3 into 6 is 18 with minus sign. Here minus 2 into 5 is minus 10. So here plus 10. Next here with minus sign minus 1 into bracket. Here 2 into 6 is 12 minus 5 into 5 is 25. Next, here with plus 4 into bracket, this 4 into bracket, 2 into minus 2 is minus 4, with minus sign 5 into 3 is 15. Now, this is equal to, here 18 plus 10, 18 plus 10 is 28, so 5 into 28, then plus 1 into, here 12 minus 25. 12 minus 25 is minus 13. Next, here plus 4 into bracket minus 19. Okay. Now in next step, here determinant of A is equal to, now here 5 into 28. Here 5 into 28 is 140. So 140. Next, here 1 into minus 13 is minus 13. Next, 4 into minus 19 is minus 76. This is equal to here 140 minus here 140 minus here 9 then 8, that is minus 89. And lastly here this is equal to we have 51. We know this 51 is not equal to 0, that is this determinant is not equal to 0. If determinant is not equal to 0, we say here A inverse exists. A inverse exists. Okay, now to find the inverse, we consider either transformation method or we consider adjoint method. Again, we use adjoint method. Okay, so here we consider each element. First is A11 is equal to, we know A11 is 5. Okay, we know its minor is M11 is equal to, here M11 is having 3 into 6. Firstly consider this A11 is in first row and in first column, so we delete first row and first column. So we consider only 3 into 6 and is 18 minus here minus 2 into 5 is minus 10 and is equal to 28. Okay, let's find its cofactor. Here A11 is the cofactor of given element and is having here minus 1 raised to 1 plus 1 into minor is 28 and this is equal to, again we know minus 1 square is 1 and 1 into 28 is 28. Next element is A12 is equal to, here A12 is minus 1, then its minor is M12 is equal to, we know this minus 1 is in first row and in second column, so we delete first row and second column and we consider remaining elements. Here 2 into 6 is 12 with minus sign, here 5 into 5 is 25 and we get minus 13. Okay, and its cofactor, here A12 is equal to minus 1 raised to 1 plus 2 into cofactor, sorry minor is minus 13 and is equal to, we know minus 1 cube is minus 1 and minus 1 into minus 13 is 13 only. Next here A13 is equal to, this A13 is 4, okay, its minor is M13 is equal to, here A13 is in first row and in last column, so we delete first row and third column. We consider remaining elements for calculation. Here 2 into minus 2 is minus 4 with minus sign, here 5 into 3 is 15 and is equal to minus 19. Okay, here A13 is equal to minus 1 raised to 1 plus 3 into minus 19 and is equal to, again minus 1 raised to 4 is 1 and 1 into minus 19 is here minus 19. Next, we consider here A21 is equal to, here A21 is having 2, okay, then its minor is M21 is equal to, here this M21 is in second row and in first column, so we delete elements of second row and first column. Okay, so here minus 1 into 6 is minus 6, then with minus sign, here minus 2 into 4 is minus 8 and lastly we get 2. Then its cofactor, here A21 is equal to minus 1 raised to 2 plus 1 into, here minor is 2, so this is equal to, again we know minus 1 cube is minus 1 and minus 1 into 2 is here minus 2. Next, here A22 is equal to, here A22 is 3, okay, then its minor is M22 is equal to, this A22 is in second row and in second column, so we consider remaining elements for the calculation. Here 5 into 6 is 30 with minus sign. Here 5 into 4 is 20. Here 20. Okay, so here we get only 10. Next, here a to 2 is equal to minus 1 raised to 2 plus 2 into minor is 10 and is equal to. Again, we know minus 1 raised to 4 is 1 and 1 into 10 is 10. Next, here a to 3 is equal to. Here a to 3 is 5. We know this 5 is in second row and in last column. So we delete second row and third column. And we consider remaining elements for the minor. So m23 is equal to, here 5 into 2 is, 5 into minus 2 is minus 10 with minus sign. Here 5 into minus 1 is minus 5. And lastly we get minus 5. Okay. Then here its cofactor. A to 3 is the cofactor of given element and is here minus 1 raised to 2 plus 3 into. Here its minor is minus 5. Okay. Again we know here minus 1 raised to 5 is minus 1 and minus 1 into minus 5 is here plus 5. Next here A31 is equal to. Here A31 is 5. So here its minor is M31 is equal to. Here A31 is in third row and in first column. So we delete third row and first column and we consider remaining. Here minus 1 into 5 is minus 5. Then with minus sign, here 3 into 4 is 12. Okay, and this is equal to. This is equal to here minus 17. Now its cofactor. Here A31 is equal to minus 1 raised to 3 plus 1 into minor. Here minor is minus 17. Now here minus 1 raised to 4 is 1 and 1 into minus 17 is here minus 17. Next here A32 is equal to. Here A32 is minus 2. We know this minus 2 is in third row and in second column. So we delete third row and second column to find the minor. Here M32 is the minor. Then is here 5 into 5 is 25 minus here 2 into 4 is 8 and this is equal to. We know here 25 minus 8 is here 17. Now its cofactor. Here A32 is the cofactor and is minus 1 raised to 3 plus 2 into. Here its minor is 17 and is equal to minus 17. Now in last we consider A33 and is A33 is 6. Okay. Then M33 is equal to. We know this 6 is in third row and in third column. So we delete third row and third column. Here only 5 into 3 is 15 minus here 2 into minus 1 is minus 2 and lastly we get 17. Okay. Then here its cofactor. A33 is equal to minus 1 raised to 3 plus 3 into 17 and lastly we get 17. So we find cofactor of all the elements. Cofactor of all the elements. Now we consider the cofactor matrix. Therefore the cofactor matrix is having elements here A11, A12, A13, then A21, A22, A23, in last here A31, A32, A33. So here cofactor matrix is having elements. Now we consider A11, A12, A13. Here A11 is having 28, A12 13 and A13 minus 19. So 28, 13 minus 19. 28, 13 minus 19. Next, for second row, we consider A21, A22, A23, that is minus 2, 10, 5. Minus 2, 10, 5. And for third, we consider A31, A32, A33. Here A31 is minus 17, minus 17, 17. So here minus 17 and 17. So this is our cofactor matrix. Okay, now we consider adjoint of A. We know adjoint of A is the transpose of the cofactor matrix. Therefore, here adjoint of A is equal to, here inside the matrix we consider for first column we consider elements of first row, that is 28, 13 minus 19. For second column we consider the elements of second row, that is minus 2, 10, 5. Then for third column we consider elements of third row, here minus 17 and here 17. So this is the adjoint of A. Okay, now we find inverse by using this adjoint of A. Therefore, here A inverse is equal to 1 upon determinant of A into adjoint of A is equal to 1 upon, we know determinant of A is here 51. Okay, so 1 upon 51 into matrix having here 28 minus 2 minus 17, then 13, 10 minus 17, and for last row minus 19, 5, 17. So this is the inverse of a given matrix. Now we consider our first point. Here in first point we see x into A inverse B. Okay, using 1 we get here x into A inverse B, and is having here in x we consider variables x, y and z. Here for A inverse we consider 1 upon 51 into matrix. Okay, matrix having elements here 28 minus 2 minus 17, then 13, 10 minus 17, and for last row here minus 19, 5, 17. Now for matrix B, here for matrix B we consider the constants. Here in the given example our constant are 5, 2, minus 1. 5, 2, minus 1. Okay, this is equal to here 1 upon 51 as it is. Next, here this first matrix is having order 3 by 3. Then this second matrix is having order 3 by 1. Here product is conformable since number of columns in first row and number of rows in second matrix. Number of columns in first matrix and number of rows in second matrix are same. So product is conformable. Here new matrix is having order 3 by 1. Here 3 by 1. Now here everyone knows standard matrix of the of order 3 by 1 and is having elements here A11, A21, A31. Okay, here for first element we consider first row and first column. So here 28 into 5. We know 28 into 5 is 140. Next minus 2 into 2 is minus 4. Next here minus 17 into minus 1 is plus 17. Then for second element A21 we consider second row and first column. So 13 into 5. We know here 13 into 5 is 65. Okay, then 10 into 2 is 20. Next here minus 17 into minus 1 is plus 7. Then for last element we consider third row and first column. So here minus 19 into 5. Here minus 19 into 5 is minus 95. Okay, then 5 into 2 is 10, so plus 10. Next, 17 into minus 1 is minus 17. Okay, and in last, here matrix X, Y, Z having X, Y, Z is equal to 1 upon 51 into matrix. Here for first, we know 140 plus 17 is 157. 157 minus 4 is 153. Next, here 65 plus 20 is 85. 85 plus 17. 85 plus 17 is 102. And in last, here 10 minus 17 is minus 7. Minus 95 minus 7 is minus 102. Okay, now we divide each element by 51. Here this by 51. We know 153 upon 51 is 3. Then 102 upon 51 is 2. And in last, minus 102 upon 51 is minus 2. So this is here in LHS given X, Y, Z, matrix having elements X, Y, Z. Now by equality of matrices, we get here X is equal to 3, then Y is equal to 2, then Z is equal to minus 2. So we find the variables X, Y, and Z by using the inversion method. That is, we find inverse first, then by using inversion method we find these variables. Thank you.